So a very good afternoon to all of you. I'm Dhananjay Kumar Mishra from Pilani. Um, right now I'm pursuing my PhD in EEE department, Pilani, and uh, my topic for the research is the frequency regulation aspects in microgrid. But right now I'm going to present this work which is based on the PV systems, hybrid systems. So we are basically presenting this impact of PV systems and battery storage in hybrid power systems with grid connection. So here are the contents, introduction and photovoltaic system configuration, modeling of PV systems, grid connected PV systems, the objective of the study results and analysis of the results, then conclusion. So first of all, I would like to introduce that the right now in the present scenario, apart from the conventional power system, the world is focusing towards the distributed generation since it is the demand of the era. And so electric power systems are basically centrally located and centrally controlled, and they are internally connected to the transmission and distribution lines based on the voltage levels. Conventional system is under transformation stage, and there are so many works are going for the modification of the conventional system to make to integrate our renewable resources into the existing grid and making the grid more smarter and more stronger. So for that, distributed generation is playing a very vital role. Uh, Now, what is a DG? Like, it is a set of electrical power sources such as renewable or as well as non-renewable sources, and they can be connected to the distribution system uh, or on the customer side also. So, and this is very much suitable for the smart grid application. And these distributed generators are playing very significant role in deregulation markets. So, from the figure you can see that which power sources are more beneficial. So if you consider conventional, they are least beneficial because they are polluting and they are creating so many pollutions, hazards. If you consider like large hydro plants and municipal solid wastes, they are more beneficial. But if you consider the green power, that includes the wind, solar, biomass, geothermal, biogas, low impact hydropower. So they are most beneficial because as far as the hazard and losses are concerned, very less amount of losses are associated to it, and also they are environment friendly. So that is why this is encouraging the authorities to integrate the renewable energy sources into the existing grid. Uh, but uh, uh, but what we see that renewable energy sources are best suitable for the remote locations like rural populations. Why? Because these rural populations or the rural remote areas, they are far away from the central power plants. So there are so many constraints like location constraint. They are located very far from the central power plants, and the cost for transferring the electricity from the generation to the remote areas are very higher. Then there are terrain constraints, like some areas are in hilly areas, some are in uh, so uh, there are diversification of primary energy supplies, then reduction of global greenhouse gas emissions and cost of energy, and again the cost of the fuel transportation for fossil fuel transportation, the choice of a hybrid system to provide a sustainable power at lower cost. So, so why rural electrification is being encouraged with renewable energy source is because it is cost effective owing to its relative lower maintenance and operation cost. So basically for rural areas, they are offering this photovoltaic system configuration, and the hybrid system can be made in two ways, like that is centralized or distributed. So based upon the inverter placing, so in centralized configuration, we have two sources like suppose PV and batteries, and there we have only one inverter present for both the sources. So this is centralized configuration. The objective is to ensure a continuous operation of the power system instead of supplying certain critical loads. What is the advantage associated to it are lower cost, little and easy maintenance. But the disadvantage is that whenever this central inverter fails, the whole system uh, goes down. So that is the disadvantage. Then distributed configuration. In this configuration, every system, every sources have separate inverters, inverter modules. So they operate in parallel. So whenever the advantage is that whenever one one inverter fails, the other source is available that time. So this system do not completely do not shut down whenever the either of the inverter fails. But the disadvantage is since the number of inverter is increasing, so it is more costlier. So, the issues with the PV system, the photovoltaic systems play a promising role in the generation of clean energy, but there are some issues like since most of the adoption of renewable energy sources such as PV result in increased penetration of unstable energy source. Now, when I am telling unstable energy source, like Jai Kishan has said that solar is not available throughout the complete 24 hours. Wind is available. And wind is also stochastic, intermittent in nature. So these are unstable energy sources. They are not constantly available. So this is the main problem that we are integrating. We are introducing an unstable source of energy into the grid. So this will be problematic. Then uh, there are stability and reliability of the electric network will come down. So these are the two issues. So basically, we have modeled this PV system. This is very basic. There are PV cell model, cells and cell series, cell module, PV array. So array consists of n number of PV modules and grid connected modules. In grid connected modules, many solar arrays are connected to meet the required voltage. So this is the system, grid connected PV system. So basically the PV system is giving some DC voltage output and it is being regulated by the DC-DC converter module, and power is being stored in the batteries at the same time. So by using some DC-DC converter control technique, and then this DC is being converted to AC for load applications, and this AC is being stepped up by the transformers. So the objective study is to investigate the impact of PV systems with battery storage on the grid. So here we used PV system and battery storage system for improving the voltage levels of the constrained feeders and achieve peak saving during the peak hours. And the second objective is to model the system and its size accordingly for the optimal operation. So these are the methodologies. To analyze the behavior of PV system, a circuit model is implemented through PSIM software. And since the circuit model with the PSIM cannot be connected directly to the grid system, so that is different software, that is Dig Silent Power Factory, is being used, in which the PV system was connected to the grid of 11 kV feeder model, and the analysis of impact of PV on the feeder has been done. That is how it is supporting when the grid voltage is falling. So that analysis we have done. You can see that DC converter and then inverter and battery modules are there in this PC. So the effective temperature on the output voltage. So from the table, upper table, you can see that as the temperature is rising, the output voltage of converter is going down, and the output voltage of each panel is going down. And the effect of when the irradiance is rising, the power output of the converter is going up. So this is DC-DC converter module. Step up, that is boost converter, is model was modeled in such a way that for varying DC input from solar panels, the output voltage should remain constant at 400 volt DC. So the below figure which shows the output voltage of a single panel, that is the red one is of single panel, 80 volts DC, and the blue one lower figure is the converter output, which is 400 volt DC. So inverter module. The output of the inverter, since it will not vary with the weather conditions, because we have applied already DC-DC converter and constant voltage control, which is making the voltage constant. So this will not, the output of the inverter will not vary with temperature and irradiance. So because the DC-DC converter is maintained at a constant level using, and then in figure 7 you can see the AC output of the AC voltage output from the inverter. After inverter, transformer has been applied for stepping up the voltage level, and from 400 volt it is transformed to 11 kV. So for peak saving application, it is modeled in the Dixieland Power Factory model, and the circuit which was modeled, the solar system which was modeled in PSIM software, since it cannot be directly tested for peak saving applications, so another identical model was implemented in Power Factory software for peak saving applications. And so this slide mainly shows the effect of connecting PV system with battery storage to feeder X. So earlier, this figure shows that the voltage profile of the feeder X before hybrid system was connected. So as you can see, that voltage profile was continuously going down. So that can make the system unstable. So to improve the voltage profile of the feeder X, the hybrid system was connected at a point in the feeder where the voltage were at 0.945 per unit voltage. Figure 11 shows the voltage profile. So as you can see, when the PV system has been turned on, when the voltage was going down, and when that time PV system was turned on, the voltage profile was again going back to the stable region. So this was the main observation. So we can conclude that PV and battery systems can be modeled for the voltage regulation and the performance, to assess the performance of renewable energy technologies in a hybrid system. The PV model is simulated with temperature and irradiance variation, and the output of the boost converter is regulated. The hybrid system made up of PV and battery successfully, and it improved the voltage of feeder X that was experiencing low voltage. And the outcome of this study shows that the model is suitable for the grid-connected hybrid power system. So thank you. There are references. Any questions?